For as long as we have been human, we have looked to the skies. The steady march of the stars, the gentle arc of the moon, the silent drift of the planets. This vast, dark canvas has always been a source of wonder, a place of myths and legends. It is a realm of profound mystery. In our modern age, that gaze has not faltered. Indeed, it has sharpened. We have built great eyes of glass and steel telescopes, peering into the deepest corners of the cosmos, ever watchful, ever waiting. We scan the heavens, not just for the familiar, but for the unknown. We search for messengers from distant star systems, travelers carrying secrets from worlds far beyond our own. This enduring vigil connects us to our earliest ancestors, who saw gods and monsters in the constellations. Today we seek not deities, but data. We seek understanding. And just a short while ago, a new and most intriguing character made its dramatic entrance onto the stage. It was first seen as a faint, unassuming smudge of light, a tiny pinprick against the velvet black. Automated telescopes, tirelessly scanning the night sky, flagged it as an object of interest. At first it seemed like just another asteroid, one of the countless rocks that orbit our sun. But as astronomers began to track its path, they realized this was something different. This was something special. Its trajectory was all wrong. It was not following the gentle, elliptical path of a native of our solar system. Instead, its course was a sharp, open-ended curve. It was clear this object was not bound to our sun. It was just passing through. This celestial traveller was given the designation 3I Atlas. The I stands for interstellar, a name reserved for the rarest of finds. It was only the third such object ever to be confirmed. The Atlas part comes from the Terrestrial Survey Telescope in Hawaii that first spotted it, a silent sentinel in the Pacific. The discovery sent a ripple of excitement through the astronomical community. Here was a new emissary from the interstellar medium, the vast expanse that separates the stars. It was a physical piece of another star system, delivered by chance directly to our doorstep. What could it tell us about its home? What secrets did it carry from its long, dark journey? The importance of such an object cannot be overstated. The visitor had arrived. The moment 3I Atlas was confirmed as an interstellar object, a global network of telescopes swung into action. It was a coordinated effort on a planetary scale. From the high, dry deserts of Chile to the volcanic peaks of Hawaii, from space-based observatories orbiting high above the Earth to radio dishes nestled in quiet valleys, humanity turned its collective gaze upon this single, fleeting point of light. Every available instrument was directed towards the visitor. It was a remarkable demonstration of scientific collaboration. Time was of the essence. Astronomers worked around the clock, passing information from one hemisphere to another as the Earth turned. As the sun set on one continent, observers on another would pick up the trail, ensuring 3I Atlas was never out of sight. They measured its brightness, size, shape, rotation. They analyzed the faint light reflecting from its surface, searching for clues about its composition. It was humanity at its best, united not by conflict or crisis, but by a pure, unadulterated curiosity about the universe and our small, precious place within it. As the data accumulated, a strange picture began to emerge. 3. I-Atlas was not behaving as expected. When objects pass close to our sun, its immense gravity pulls them, accelerating them along a predictable curve. But 3I Atlas was deviating from that path. It was moving with a slight but unmistakable extra push, as if some gentle, unseen force was nudging it along its journey. This phenomenon, known as non-gravitational acceleration, is often seen in comets. As a comet nears the sun, its ices warm up and turn into gas, shooting out in jets like tiny rocket engines, altering its course. However, there was a problem with this explanation. Comets, when they outgas, form a visible halo of dust and gas, a beautiful glowing coma, and often a long streaming tail. But 3. I-Atlas had no such features. It remained a single sharp point of light. Telescopes saw no dust, no gas, no tail of any kind. This was deeply puzzling, a celestial contradiction. The moment of truth was planned with military precision. As 3I Atlas made its closest approach, the most powerful telescopes we possess were trained upon it. The hope was to capture a definitive image, one that could finally resolve its shape and perhaps reveal the source of its strange acceleration. After weeks of tracking a faint, distant dot, this was the chance to see it as a resolved object, however small. The tension in observatories around the world was palpable. The data was collected, the data was processed, the data was combined, and then the final image was assembled. The revelation it contained was something no one had predicted. The image was, honestly, breathtaking. 3. I-Atlas was not a single object. It was two. The image clearly showed two distinct pieces flying in close formation. They were separated by a small but stable distance, orbiting each other as they tumbled through our solar system together. This was the answer to the mystery. It was a binary object, a pair of interstellar asteroids locked in a delicate gravitational dance. The strange behavior, the non-gravitational acceleration, was not from outgassing at all. It was the result of the complex, subtle interplay of gravity between the two bodies and the Sun. The visitor had finally revealed its true nature. Before 3I Atlas, there was another famous interstellar visitor. It was called Oumuamua, a Hawaiian word, meaning a messenger from afar arriving first. Discovered in 2017 side by side, Oumuamua, artist impression left vertical bar, 3I Atlas. Telescope image, right. Oumuamua was the very first interstellar object ever detected, and it was deeply strange. It was small, dark, highly elongated, shaped like a cigar or a flat pancake. Most mysteriously, just like 3I Atlas, it also showed non-gravitational acceleration. It, too, was pushed by an unseen force. But Oumuamua was moving too fast and was spotted too late for us to get a good look. It remained a mystery, a fleeting glimpse that left us with more questions than answers. But this time, we were better prepared. We had the chance to get that crucial, high-resolution look that was denied to us with Oumuamua. It was gravity, acting in a beautiful and complex way. So, what can this binary traveller, 3I Atlas, teach us about the wider universe? Its very existence is a profound clue. The fact that a binary system, two objects gravitationally bound to each other, could be ejected from its home star system and survive a journey of millions of years through interstellar space is remarkable. It tells us something about the violent and chaotic processes of planet formation. It suggests that the birth of solar systems can be a turbulent affair, with objects, even paired ones like this, being flung out into the void with tremendous force. These are not gentle nurseries, they are dynamic and sometimes destructive arenas. Furthermore, studying the composition of these two fragments gives us a direct sample of the raw materials that were present in another solar system long ago. By analysing the sunlight that reflects off their surfaces, we can determine if they are rich in carbon or silicon or perhaps exotic metals. This information is like interstellar archaeology. It helps us understand the diversity of planetary systems across our galaxy. Are the building blocks of planets everywhere the same as they were in our own solar system? Or do different stars cook up different ingredients? 3I Atlas and its companion are two small pieces of an answer to that grand question. The discovery also opens up a new field of study. We now know that interstellar binaries exist and that they can be identified. Future surveys will now be on the lookout for them. We have a new class of object to search for in the cosmic darkness. Understanding how common these systems are will help us refine our models of how planetary systems evolve. Each new interstellar object discovered will add to this growing body of knowledge, allowing us to piece together a more complete picture of our galactic neighbourhood. 3I Atlas was not just a curiosity, it was a trailblazer, showing us what is possible and what to look for next. Perhaps most importantly, 3I Atlas provides a powerful lesson in scientific humility. It reminds us that the universe is under no obligation to conform to our expectations. We expected a single object, perhaps a comet or an asteroid. The universe sent us a pair of companions on an epic journey. The story of 3I Atlas is more than just a scientific report. It is a tale of wonder. Two rocks, born in the orbit of a distant unknown star, travelled for eons through the cold and the dark, then passed through our small corner of the galaxy for a few brief weeks. The endless frontier is above our heads, waiting.